Good afternoon. Everyone had lunch? Everyone's fed? Oh, shocking. All right. Today I get to talk to you, if my clicker works, about building UI. I want to give a quick introduction to myself. My name is Chris Anderson. I've worked at Microsoft for since before I could drink. I have worked on many of our UI frameworks. I've worked back in Visual Basic on the internal Ruby framework we had there. I worked on Visual J++ on a very not often used WFC library, not to be confused with WCF. We like to reuse our acronyms. And most recently, I've worked on both the XAML framework and the DubDubA framework, the WinJS libraries. So I've kind of been around the block and looked at a bunch of UI. And one of the questions that I hear a lot these days is, should I use XAML or HTML? Because clearly there is a right answer, and we're just too slow to tell you. And then they say, well, if you can tell me about XAML and HTML, then you've got to be able to tell me if C# or C++ wins. Because, again, there should just be one answer. We should all program in something else. And then the next one is, of course, hey, I'm using feature X, and it's not fast enough. Please make it faster. As Steve said in the keynote this morning, the performance is getting to be a bigger, I guess it was Antoine actually, performance is getting to be a bigger and bigger problem on these devices. And so it's becoming a more prevalent question. How do we make things fast enough to run on these low power devices as they get smaller? So within this, there's kind of an interesting problem, which is the set of apps that people want to build is incredibly varied. And there are ones that you look at and clearly you look at that and you pattern match and you say, well, that car racing game, I bet that's got to be DX. And you look at the paint program, you're like, well, I don't know, maybe that should be XAML, maybe it shouldn't be. The mail app, I don't quite know. Some of these don't have very clear guidance. Should calc be written should it be written? But once you decide you like to do math and that we don't like to do long division, you say, yes, actually, it should be written. We're going to move on. So the thing I'd like to do is, before we really drop into kind of the nitty-gritty details about what the trade-offs are between the different UI frameworks, between XAML, DX, and HTML, and kind of walk through kind of some of the pros and cons there, I want to put some framing around this. In the end, we're about building an app. You typically have something you're trying to accomplish with that app, and there's often services associated with it. There's data you want to get, and in the end, you want to deliver real value to your customer. And so starting by thinking through what the actual value it is. Typically when you have an idea, the first thing when you write on that sheet of paper isn't, should it be XAML? And so really there is this temptation to jump to the end, and you want to kind of walk really through the business value and what you're trying to accomplish. And with that, I've been struggling with how to walk through this topic, because I internally at Microsoft, when people come and talk to me about the apps they're building and what they're doing, they often have that question also. Hey, should we go build the new, movie app in XAML? Should we go build the new whatever app in HTML? And it really comes down to kind of a complex set of trade-offs, and there isn't really a one-size-fits-all answer. But there is some guidance we can do. So one thing is, you have a team of people. You have people, and software is made of people. Those bytes don't manifest themselves. The MakerBot doesn't yet have a way of producing code. And so what experience do they have? What do they build? What do they know what to do? What kind of designers do you have? What do they like to work in? And these can actually drive some of your decisions, and that's okay. You also have a question about what assets you already have. One of the biggest assets you can have is another version of your app. Like if you've already built it for one platform, that can really influence the decision that you're going to make about how you build the application. Do you have a bunch of graphic resources? Do you have a bunch of 3D models that were written in a specific library? That library, the 3D library, could actually say, oh, well, we have to use DX for a large portion of our app because we can't possibly rewrite all of those into WebGL JavaScript or something like that. That can really impact it. And those assets can often be the most expensive part of building your app. One that I think people tend to overlook, if you've come from a client-centric point of view and kind of building apps, is that apps have an ongoing operation cost, and that cost is real and can have a drastic impact. And so you have to think through, are you going to update this app? That may sound like kind of a weird question, but there's a lot of apps for which your monetization strategy is to sell it once and never touch it again and move on to the next app. And so you don't care how expensive it is to maintain the app because you're never going to fix a bug in it. No comments about our software, please. And so really, there's also the traditional ongoing operations cost around services, et cetera. So last one, not the last, second to last, is about getting paid. In the end, a lot of apps are getting developed for one of two reasons. You're either developing it to reduce cost of a business, you're working in an enterprise, and your goal is to reduce the operations of that enterprise and drive costs down, in which case you have kind of an inverse on how you get paid. Or you're trying to build something, put it in the app store, and actually make some money on it. And you have to think through how you want to monetize that, and what are the monetized assets you want to sell. So when you think about a game, for chance, right? So if you're going to go build a game and you think through it and you're like, well, the thing I want to sell is level packs. Well, you're going to want to optimize your architecture of your app such that levels can be cheap to build. Because they're the things you're going to want to increase and produce a lot of and sell at a really good price and make a lot of money. But if the thing you're selling is art, then you're going to want to have a different thing. So like Freshpaint, I think, has these art packs that you plug into it and that you can go buy those. And so for that, you want to think about, well, what's the way that I can have artists create those art that I can then resell? And so you may want to change the way that you render images to best use that thing. And really, the math here, this ARPU minus CAC times churn equals ops, or minus ops, is profit. There's this equation about how the money you make for each customer, the number of customers that churn, how much it costs you to get that customer, and the operations cost is what you get to put in your pocket at the end of the month. And that formula, the technical decisions you make about how complex the software is, how much you have to pay the engineers that you need to go build, how long it took you to go build it, how quickly you can update it, can radically impact that cost structure. I'm not going to spend a lot of time on the monetization aspect. Arik has got a great talk on all the new monetization stuff we're driving to the store, but it's definitely one of the hot topics in app development is really how do you maximize that profitability. And the last point I want to touch on is really this one about devices and form factors. Windows devices come in a wide variety of spectrum of shapes and sizes, but of course there are some other manufacturers that make devices also. And for those, you've got to think about how you're going to leverage code across those. And if you make a decision, you may impact how much of your code you can reuse. If you write things in, ANSI C, that's pretty much going to work no matter where you go. If you choose to use, JavaScript and HTML, that's pretty widely supported on all the platforms. If you go and do, Objective-C and C#, well, those are less reusable because they're tied to a platform. But there's other benefits to those. But it's something to think about when you think about this debate about how you want to go and build your UI. And so the last thing is the one that everybody starts with, which is hey, what language should I use? What framework and how should I author my content? And really, if you think about the details of that question, your language really adjusts a couple aspects of the actual user experience that the customer hits. There's a performance issue to it. There's a cost to how much it costs to develop it, which affects your profitability. And here, there's both the team productivity, the familiarity of the language, and the innate productivity of the language, if you will. It turns out that C, if you want to code an assembly language, it just takes a long time to type all those characters. And another one that some people sometimes skip over is this notion of access to libraries. Choosing a language for your app can actually drive a set of libraries that you can or can't use. There are add SDKs that you may want to go integrate that require your app to use JavaScript, for example, or require you to use C# or something. And then finally is this notion of, the language is going to cost support. Like, you're going to have to pay engineers to go fix bugs in that code, and that can drive the cost of how much it is to support it, which eventually gets to your profitability. And the UI framework has a similar set of trade-offs around user experience, the development, and it has this other one, which is this notion of some specific features. There are gaps, there are differences between HTML and XAML and DX in terms of what features you can get to. If you want to write a custom shader, you have to go down to DX. If you want to go do, I just lost my train of thought. To the next slide, you press next. So let's dive into this and really go through some of the actual trade-offs. What are some of the trade-offs in the platform? And one of the themes that you're going to hear me talk about a lot is performance. And really this comes down to this trend that's going on right now, which is machines are getting relatively slower. Every year we come out with brand new CPUs that seem to be better and better and faster, but the net result of the machine is that it often feels like it's getting slower. As the DPI goes up on the device, as the GPU gets more overloaded, we continue to consume all those resources, but the batteries aren't getting miraculously better. Regardless of where we see things going, you really have this problem of the experience you deliver per watt is a critical measurement. So if you max out the CPUs on all the cores, your app is going to drain the battery in 50 minutes, and everyone's going to hate your app and hate the platform. And so you got to think about how you're going to budget this experience. So as I walk through these features, really my goal here is to give you an idea, a way of thinking about the features in the platform and how to make these trade-offs, how to think about the choices and balance them against the user experience. So when you think about using a high-cost feature, something that makes the developer's life radically better, you have to think about the balance of what you're taking away from the user in terms of battery consumption, in terms of the experience that they're going to deliver. Because in the end, every feature has some amount of cost. The longest life battery is going to be the black screen that's turned off. So in the end, you want to pay some of those costs. So let's start our tour through some of these things below the XAML layer. So we're going to go through XAML, we're going to go through HTML, we're going to go through DX. They share a common base. Below both HTML and XAML is this common DirectX set of APIs, and really this defines how we talk to the hardware. So the speed of light on these devices is largely determined by DX. The amount of the fill rate that you can get pixels on the screen is the GPU. The fastest way to get to the GPU is DX. And so there's still a budget. The more you overdraw, the more textures you upload, the slower your app is going to be, the more memory you're going to consume, the more battery is going to go away. But it also is the thing that gives you the access to the raw pixels. So I'll briefly jump over here and show a quick demo here. I'm going to go through and do a bunch of these little kind of small demos to walk through the various performance. And so this is a variation on the default VS, the template for XAML with DX content in here. And so in the middle here, I have this DX surface. And so this is on a Surface RT device. You see I can create, we're still getting 60 frames. Still getting, okay, now we're dropped down a little bit. We can really just kind of try to kill this thing and put a lot of pixels in. But you see, we can get relatively good performance. We're creating quite a few triangles there. We're pushing them up. It's working out. That's kind of the fastest we can draw these polygons is at that speed. However, going back to the cost that the developer has, let's look at how I had to render those. So I'm going to skip the 900 to 1,200 lines of setup code for my D3D surface. We'll just pretend we all saw that. Okay, so here we get to our allocation of the vertices. So we go through our vertices, we create some float threes, we allocate the size, we create a buffer, okay, then we create a surface data, we go create the position colors, we push those in, create cube indices. Well, it turns out that to actually render this quickly, you have to know that updating the vertices is actually faster than calling update sub-resource on the graphics card because that's a chattier protocol. So we want to do one D3D call, and so we're going to build up this huge mesh of every one of the triangles that's on screen at once and do one call. And so then we create our index buffer, and we come down here, we clear out some temporary variables, we create our vertex, but we're still not there. Keep going. Okay, oh, here we go. That's our call. That is drawing all of those triangles. It's, and if you want to add something besides rectangles, the code, doubles, quadruples, gets much larger. So, we now know the baseline performance of the system, but we also know that that's going to not be super cheap to go build. When we think about that matrix of what our profitability is going to be, that's going to be hard. But that still defines the baseline. That's the experience you can offer. We can get thousands of polygons flying on the screen at every frame. So you say, that's too hard. I want to go one level higher. I want something to draw the rectangles for me. I would like to do a beautiful API, D2D, which gives us nice vector drawing and it lets us, run our code. It's great. So how much does that cost us when we go over to D2D? So we're going to take that same app. slight variation, and we're going to draw here. So we see already we're down to 34 frames a second. I can add some more. It's still in the 30-ish, kind of 20-ish, but we've lost almost half of kind of what we had there but we've also gained a ton of developer productivity. Like there is a call in D2D, draw a rectangle. It's way easier to code against. And so we've made that trade-off, but we got the performance. D2D, when you look at high-performance games, they end up doing things like using Cocos 2D or doing 2D on top of 3D to go draw things. Because for them, they need a super, super fast sprite engine, and they're willing to sacrifice a ton of stuff to get the max throughput on this. But really, for vector drawings, that's still really fast. It's still actually quite zippy. So let's actually, just for comparison, let's go take that same app. Sorry to keep switching screens on you, but let's take that same app and go and do that with a XAML canvas. And so what we're going to do here is we're going to use, I named all my apps too similar. There we go. So this is XAML canvas. This is declarative. This lets me go, in here I'm now setting things like canvas.top, canvas.left. It's very simple code. And you see that even with a single point, I'm down to 40. Once I add 2 fingers, I'm going to get to 30, 20. And so I've given up a bunch more performance, but I now can create shapes. I can style those. I can create a data template for those. There's a ton of services that I got out of that. So you can see, as you go up the stack, there's a trade-off. It's not a XAML wins over THID or any of that. So that's kind of on the vector drawing side. And the other thing we want to talk about that I'd like to go through on the DX side is text. So drawing text to the screen is one of the most complex things that can be done in computer science today, I think. It is, when you think about all the languages, the BiDi, the fact that you need to be able to support things like furigana, which is notations above the Japanese characters for the pronunciation, like getting all that stuff right is incredibly hard to get right. And so people tend to think that, well, the way you write fast text is you go back to that DX version, you create an atlas of images of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you just map those into rectangles and you draw and away you go. And that'll be blazingly fast. And it will be until you need to put a single character of text. And then you have the problem of it's not right for any language. It's not anti-alias, it's not this. And so we have this great API, which is the bottom of all of our text. So XAML uses this API, HTML uses this API, everybody goes through DWrite. And DWrite, it has cost, yes, but it's also pretty darn fast. So we're going to talk about DWrite here. I'm going to say, so this, I think I may have made my font a bit too small. This is 200 randomly generated strings updating every frame at 60 frames a second. And that's going through the DWrite code base, and so that's filling a lot of text. It's doing a lot of thinking. I could go add in international characters and it would still render correctly. Like, it's pretty good. If I take that same thing and I say, well, let's go add in, let's go instead make that be a XAML-based thing. We'll see here, same 200 things, and we're down to 9 frames. So the question you might ask is, well, what did I get for that? So I gave up a bunch of perf. And this is obviously, to be clear, this is a stupid micro benchmark. It's to illustrate a point about the relative cost of things. What I get out of this is each one of those is actually fully accessible. I can go touch one of those with Narrator and it'll read back to me the value of the string. I can go walk that with the DOM Explorer. I can style it. I can hit test it. I can have a click handler. There's a ton of things I'm getting out of that would be incredibly hard to go replicate on top of DWrite, and it's not clear you'd get it any faster. It's just that you want to understand the trade-offs of that. And so, for example, if you're going to have a chart with 10,000 data points on it that are randomly animating to show real-time values of a music sampler, you probably don't want to go at this level of the system. You want to drop down to DWrite or D2D or even all the way down to D3D. You need to pick the right tool for the job, for the right part. Your menus, no problem. This is plenty fast. You're probably not updating your menu text 60 frames a second, or your users are going to have problems. So that's our tour through DWrite. That's our DX, kind of the base of the system, the low-level nuts and bolts, and it's kind of the area that typically when I have this conversation with people about how do you choose UI frameworks, they often forget that we have this really powerful engine at the bottom and that you do need to think about the trade-offs. So XAML is an awesome framework. I've been working in and around XAML since we started it. And it is spectacularly, you're looking like, oh, thank you. You like XAML. That's good. XAML also is very feature-rich. Turns out those features, as with all, have a cost. And so it's interesting to walk through and think through that when you use these, it's not an all or nothing thing. When you pick up XAML, so the idea of whether or not you use XAML or HTML or DX, part of it is which parts do you use? When you think about it, if you drop in and say, you know what I'm going to do? I'm going to write everything where every single string in my entire UI, every point is all data bound to a view model. I love view models so much. I'm going to have a view model that says the X and Y of my buttons. It's probably not going to be very zippy. But on the other hand, like, just by using XAML controls, I get a ton of stuff for free. Like, it turns out that the XAML base, when we use in XAML, when we go talk to the DX layer, we're very smart about doing things like caching primitive bitmaps so that we can make it zippy. So if you use a ellipse in XAML, it's actually pretty fast. I was trying to do a preparation for this talk, and I was doing some demos of A/B of D2D versus XAML. And my first cut at D2D was slower than XAML, by far, because I wasn't caching the primitive bitmaps. I was able to eventually get it to where you see where there's some performance deltas, but XAML's pretty zippy. So I don't want you to get the impression from this as we walk through the pros and cons that XAML's slow. It's mostly about what's the trade-off you're making? What are the features you want? So for example, binding. So binding is awesome. It enables a ton of scenarios about being able to separate concerns. It has a bunch of features where you can go and say, I want to have a view model that can change. I can data bind that to multiple UIs. I can have the same piece of data show up in multiple places. But there's a cost. Like, that binding does have a cost. If we go back to our silly text example, I'm going to go and take that same text and I'm going to replace it with a data-bound version of that text. So here what we have is 200 random strings in a view model data bound to the UI and updating every frame. And you can see it's about 1 frame per second slower. So there is a cost. Just the act of data binding the values slowed this down by 1 frame per second. That's roughly a 10% slowdown. That's not terrible. That trade-off may be well worth it. Binding can add a ton of value to your app. But when you use binding, you should think about it. Like, hey, does this part of my app need binding or not? So the next one is animation. Fast and fluid. Everything should animate. Everything, like if it comes in, it should transition. And if it's going to transition, there should be a storyboard, and it should have bounce animations, and it should be awesome. And that's great, and that also costs a ton of performance issues. Simple things like, when your app goes to the background, you should stop ticking your animation. And all of that stuff is handled for free in a lot of ways by XAML. But those XAML animations do, again, you're noticing a theme. You should all be noticing a theme. They have a cost associated with them. So I want to talk a little bit about 2 examples here. So the first one I want to show is this guy. Okay. So this is not a late-night psychedelic-induced demo. This is trying to show kind of the performance of animating what should be the fastest thing in the world to animate. Simple bitmap, texture, X, Y, rotate the guy around, spin it around. As I touch the thing, go capture it and create another one. So this here I've written with D2D. And so we can see I can add more things, and we'll draw some more, and we'll get up to, let's add some in. So we're at, 500, and we're down to 50 frames, or 429, we're down to 46 frames. And so that's not bad. And think about that. Every frame, I'm redrawing everything on that scene every time. So we're getting a lot of really good throughput on this little, whatever it is, 8-month-old device with a GPU that can run forever, and it's, not bad. So let's go look at a version of that instead, well, here, let's actually show the code first. I want to show the code of how we do this on the XAML side. So on the D2D side, we end up with code that looks roughly like this, which is we go through and we say, hey, we're going to go and render, we're going to get a drawing context, we're going to have to transform it, we're going to draw a bitmap, and we're going to do that every frame, and then every tick we're going to update the location of these things. And so, it's not terrible code, but I'm managing all that, and if I wanted to change any aspect of that, like if we go look at the way that tick is implemented here, it's hard-coded to apparently add a dangle to my angle. So that's not terrible. But if we look at the XAML version, the nice thing we see about that is here. Sorry. Here what we do, I do it in code, but what ends up happening is I create a bitmap, and I'm able to create a double animation, and I give it a duration, I can say how long it's going to take, I can say that if I want to have an easing function on it, do I want it to repeat, there's a bunch of stuff I can do very easily and very declaratively, which is great. It's definitely a much better way to build that animation than hand-rolling my own math, and as that got more complex, yes, simple interpolation is easy, but it doesn't scale over time. And if I go look, kill that. So here, and we see it it's great. 60 frames a second, spinning guy, it was easy. And when I do the XY location, there's a canvas, I can hit test those, it's awesome. But of course, as I up the count, it slows down faster. And it gets chunky, and you see that on the UI, it starts to get it doesn't follow my finger as nicely, and all this because we're doing more work on the UI thread, and so there's a cost associated with those animations. And so again, if we go back and we think about that chart example, if you're going to have thousands of data points animated, if you're trying to emulate a particle system, I want to do some effect where things explode off of this when you touch your finger down, you probably don't want to do that with a canvas with 10,000 points and try to do animations for them, but rather do something else. And so again, here's an example where you just want to know the trade-offs and you want to know what the impact is of those given features. So of course, Antoine talked this morning, we made a bunch of improvements in WebView, and in XAML, the DX interop story has been vastly improved. This is one of those examples where XAML really has some unique features in terms of interop. The ability to drop a swap chain panel. B. Jordan's doing a whole talk on DX interop and XAML, and you can do just amazing things. Every one of the demos I've been doing so far that have any DX content in them are actually all XAML apps. And they host a D2D or a D3D display in them and are able to composite them and do all of that stuff. It is very powerful and from that perspective. And so if you really need that level of integration, this is one of those examples where you have a feature that may drive your decision. It may say, if you really need to integrate D3D content directly into XAML or into your UI, then you need to go to XAML. The WebView is another one. We've made incredible strides in the WebView for performance. And we're able to, in this version, we're able to do even silly things. So for example, this is a app that you can't see. It looks really cool, though, trust me. UI that everyone should build into their app. And so what I have on top here is a XAML text box. What I have underneath is a WebView control that's actually pointed to a WebGL demo site. So that's WebGL hosted in a WebView, hosted in a DX surface, hosted in XAML. There is a cost to this, though. If you think about the number of layers that are getting composited on the video card. So let's just start at the hardware, work our way up. So at the video card, that 3D surface in the middle has to get composited because I put an alpha on top of the whole thing. So there's an extra operation that's going to occur there. And then I have a bunch of alpha on top of it, and then I'm animating it. So I have an extra set of surfaces on top of that. And so I have a fill rate of this app is actually quite a bit worse than just hosting that 3D content by itself. Then you have to think about the fact that I loaded Trident, DX, WebGL, XAML, and if I chose to, I could have had this in C# as well, just to see how many things I could load. So the working set of this may be a little tough. And so as you think through, the fact that you can doesn't mean you should. All right. So next, my favorite hot topic. My favorite topic. This one is so fun. The debate over what is the one language to rule them all. I still say it's Lisp. But we have a good number of options in the Microsoft ecosystem, and some people would say that we should really go down to one. We should just pick a winner and we should abandon choice. I tend to like the choice. I think that it's about trade-offs, but it does mean that you have to think more when you go and approach the problem and think about what the trade-offs are. And so really, you kind of have these three choices of how you want to code your app. One is with vanilla bog standard C++. Now, of course, to talk to your UI, you're going to end up going through WinRT API. You're going to end up touching some amount of CX, but you can really isolate that CX down to just the bare minimum that you need to do to talk to WinRT. And you can write the vast majority of your app in C++, or even C. You can then do the whole thing in CX, like the initial VS templates from last year, or from last year, were actually very heavy in CX. Like if you said file new project C++ app for XAML, every class would be a ref class, and it was kind of this thick layer of CX, and that has costs. And then finally you have C#, which we love C#, man. That is, I love C#. I worked with C# when it was so cool, and it's just, no one got the joke. No one was here back then. I feel sad. Anyway. But so there's this interesting trade-off. So to demonstrate this, again, similar to that crazy, data-bound thing, I went online and I found an interesting algorithm. And the interesting algorithm is A*. And what A* is it's a pathfinding algorithm. So I can create these little paths, and I can move my guys around, and I can make this guy move wherever I want. And what he's doing is, as I move these things, he's calcing the best path to my end result from the top to the bottom. And so to test this out, I said, okay, well, let's go create that. And the A* algorithm it's a pure CS algorithm. Like they've been debating the right pathfinding algorithms for decades, and there's A1 and A2, and then some guy said, I'm going to unify them all, and I'm going to create A*, and then there's 1,000 varieties on this. But it's interesting because it is a very pure algorithmic thing. And so I said, great, I'm going to write the fastest version I can in C++. And so I did this. And so here, I have 2,500 cells that have to be considered. I run through them 10 times, and I can achieve 30 frames per second. And so there's the rendering cost of this. I only render once per frame, and so this is, there's almost no rendering cost here. It is pure computational complexity. And so I can get 30 frames. If I take that same thing, and I just change the implementation of some of the classes to be CX, I drop down to 18. And if we look at the delta between the code for those two, you'll find that there's one or two extra ref classes in the mix for that whole algorithm. And so there's this cost. I mean, this is a super tight algorithm. So I've injected a CX ref class right in the middle of this tight loop that I'm running tens of thousands of times per second. And you can see that it has an impact. And so that won't have an impact on every app, but it does. You need to think judiciously. The guidance we have around CX is that you should be careful. You should use it on the edges. CX has overhead. It adds ref counting. Even with shared, even if you use STL's shared putter in C++, you can have performance problems. And CX just kind of does that for you naturally. And so then the question is, what if we write that in C#? Okay, so first, we saw 30 frames a second in C++. We saw 20 frames a second with a couple ref classes added. What do you guys think it's going to be for C#? Wow, this is awesome. I heard 50, 43. 3 is an interesting guess, okay? Clearly, that would be what I would show you at a Microsoft conference. Let me show you how crappy C# is. Oh, it's so bad. So the interesting thing is, it's 20. It is slightly faster than CX. And it's interesting. I found it interesting that it's faster than C++ with the component extensions. That's interesting to me. It was an interesting data point. The other interesting thing that's worth telling a little bit of a story is, up until last night, that demo didn't look quite as good, because the C# was actually going closer into the 3 range. And it turns out that writing fast code in C# requires you to understand C#. I know it's a shocking statement. And if you write the naive C#, so let's view our history. By the way, I'm using a Git-hosted project on TFS Online in VS 2013. It's awesome. So review our history on this little A star, and we'll look at this little fixed C# perf issues. And we'll go diff this. Oops. Apparently I won't diff it. View history. Commit details. Come on. Right now I'm using my cell phone as a Wi-Fi hotspot so I could make sure some remote debugging scenarios work. So see how that goes. Okay, so we see a little diff down here, and the interesting thing I want to bring your attention to is this change. So, oops, right here. So if you look on the left, the old, slow, busted, horribly evil, how could you ever imagine you'd want to do that, which uses list of uint, and the awesome, hot, fabulous, kick-butt version on the right, which uses an array of uint. So again, we're tight in the middle of a loop. We're in the middle of this tight loop. This is this A-star algorithm, which you get, you basically get these data points, and they're all in-spaced, and they're indexes, and you go query the thing, and you keep track of the best cost of how you go through the loop so you can do prune out bad choices quickly. And in the end, we got a 50% performance improvement almost by switching this intermediate guy to a tight array loop, and in fact, doing tricks in here like implementing append ourselves. And I can see that the dev the guy who was hacking on it last night, he thought, oh, maybe I should really actually do move memory and like crazy stuff like that. So luckily he didn't think he needed to do that. But really, it's very interesting, which is that even within C#, we talked about XAML and data binding and the animations and the cost of those, but even in C#, you have the same set of trade-offs you need to think about. Every virtual call you make actually has overhead. And when you go through list of T, there's a bunch of virtual calls, a bunch of allocations that occurs, and you need to think through those costs. When you really are thinking about experience per watt and thinking through that, you need to understand the cost and the ramifications of those individual decisions. Great. Awesome. Okay, deep cleansing breath. XAML. We love XAML. We love HTML also. I love HTML. We have made so much progress in the web platform and making it be a great development and allowing you to write native apps in HTML. It's fabulous. I really enjoy this. And in fact, one of the big things I think, when I think about making the decision about XAML versus HTML, one of the top questions I would ask you is, do you have assets? Do you have assets already existing? So one of the things I did, I said, hey, for this talk, I should come up with an interesting asset that I'm going to imagine already exists. And so I fired up my browser and I said, okay, I'm going to pretend, because one thing I could do is I could go try to port a website. And I said, yeah, I'm not going to port a website. What I'm going to do instead is I'm going to go find a popular library out on the web. And so I said, this WebGL thing, I hear it's going to be big someday. And so I said, okay, let's go look for this thing called 3JS. And 3JS, which I know the org site, is this cool website, cool library, which is all a WebGL, retain mode wrapper on WebGL. And so they do cool demos in here. So let me pull up one of these guys. Remember, this is all running over my cell phone, so you guys, I'll take up a collection later to pay for the charges. But it does crazy stuff like this. So it's all JavaScript, right? Like, amazing. Now, of course, this is running on my crazy Core i7 beefy laptop, 8 gigs of RAM, fabulous machine. So it's like, it's never going to blink an eye at 3D like this. But it's awesome because I got this JavaScript library. I'm like, I want to put that in my app. So I'm going to go download that and put it in a silly little JavaScript app. And so I thought about this Sunday night. Yes, I wait that long. And so I came in here, and so here is 3JS from that site. Awesome. Fabulous. I can know how to program this. And then I went to their site and I said, okay, tell me how to draw a cube. So I went to 3js.org and I said, okay, great. So somewhere in here is a tutorial. Shouldn't have closed the browser. Okay, great. It says getting started. Getting started. Okay, awesome. It walks me through, sets up lights, sets up cameras, blah, blah, blah. And at the end, you have this cool, they did a sphere geometry. We end up with this thing. So this is the learning I did. It took me 10 minutes to go grab this, 10 minutes to go learn it. And I go put it into this project, and I say, okay, great. Here's my little project. Let's go run that. And so we're going to go run that. And the code we ended up writing, of course, is we just wrote a little JavaScript. Where did I put the JavaScript? It's in here somewhere. The app runs. I know there has to be JavaScript in here somewhere. I hope the app runs when I put it on the machine. Defaulted HTML was empty. Oh no, hey, look, I committed, oh my goodness, that's horrible JavaScript. You never should put this, don't ever put JavaScript in an HTML file, okay? It's bad practice. So here, we create a WebGL renderer, we create a cube geometry, we create a Lambert material, of course. We create some cubes, we create a camera, create a light, on pointer move, we move the camera around, and then on render, we just rotate each cube. This is like super simple JavaScript, and I learned this on the web in 10 minutes, and now I can go put this into my app. And so to me, like the fact that there is this insane amount of libraries out there on the web that let you go build things like this in JavaScript in just minutes is one of the powers of HTML. Like there is a huge community that just does crazy, crazy stuff on top of this platform, and you can go grab any of that, inject it into your app, and build a native Windows app like that. And so really, like, I don't know, and so this is running, again, on my crummy, on my RT device, and so, you know, we can get good performance, like WebGL, it's awesome. It's fabulous stuff. Great. So that's one of our big pros. XAML had this big pro of like crazy integration that you can go do. HTML has this big pro of all these crazy libraries you can go do. So you can see that there's this trade-off of what you need to go do. So let's do a quick tour through some of the features of WinJS and make that same kind of trade-off we talked about on XAML of like, oh, binding's not that bad, but you should think about when to use it. So WinJS has binding as well. How does it play out? And so one of the things is in WinJS 2, in the same way in XAML, we did a huge number of performance improvement in 8.1. Data binding is markedly faster in 8.1 in XAML than it was in 8.0. We've made huge performance improvements. And in WinJS, we've done the same. We've invested heavily, and we actually we pre-compile templates now to generate code so that it can be as optimal as possible. But you still have this question about, hey, templates, bindings, intertext. There's a hierarchy of things. Intertext should be the fastest, binding should probably be middle, and templates are probably the slowest thing to go do because they go and do all this work. And so I said, let's try. Let's go look at this. We'll look at the code for this one in just a second because I think it's interesting to look at. But let's go look at this. So this goes and iterates, creates a bunch of text blocks, and iterates and updates each one of the text blocks through a data-bound string a couple hundred times. And if we look at the top, we see the performance is actually that binding's the fastest, and setting the inner text is the slowest, and templates are kind of in the middle. That seems counterintuitive. So I said, self, you should figure out why that is. So I grabbed the VS Tools. I'm very excited by this because I hadn't used the VS Tools yet for some of this stuff because these things come in late and we're building a platform and we don't know always that we can go do this. And now I am going to tempt the demo gods because I'm going to try remote deploy and remote debugging over my cell phone on a Wi-Fi. And we're going to see how this goes. Ignore the failure. It'll get better. No, don't continue. If it didn't deploy, why would it think it could continue? The bits aren't on the machine. Okay, we've deployed. I can see it, you can't. It's very exciting. So now I'm going to bring up the new VS Tools. I'm going to say, I'd like to find out that HTML UI responsiveness. I want to try to figure out why why binding was faster. And so we're going to start it. The app is going to start. Again, it's going to be exciting for me. I'm going to watch it run. You're going to watch this thing spin. Because by the time I switch monitors, it'll be done. So it runs, it's thinking hard, time is computing. Trust me, it won't be much longer. There we go. Stop collection. Okay, so we ran the app, collecting the trace, going over Wi-Fi. We got our Surface, which ran because we're just general. You should only ever do perf tests on ARM devices. Like, ARM devices will always be your slowest devices. They are the slow thing. And if you ever want to do perf numbers, you want to collect perf numbers, run on that. That'll tell you what your bottom line is. And then it'll always be great on everything else. And so here's our stats. Okay, so here we see, and I have these little trace markers, and it says, okay, that's where the binding sample ran from. Here is where, mouse over it, the template did, and here is where the query did. It's like, well, why would this guy be faster? And if you look at it, you're like, well, one of the things I noticed is it didn't run as many script blocks. The script didn't seem to occur. And if we scroll down through here, we see a bunch of stuff happening. This is what you get for doing a demo. I should have screenshotted this before. We'll see things like this, where the timer kicks off and then another timer kicks off. You're like, well, why is that? Now, luckily, I know why that is. You may not. But when you look at this, you can see things like that there's this timer that kicked off and that's not an immediate timer that didn't. If you were debugging your app instead of debugging the framework, in this case I'm trying to debug why my binding was faster, because I worked on binding and I want to know why that was there. And the thing I remember is that WinJS data binding is asynchronous. And so while I was running that binding as fast as I could, WinJS just chose not to update the UI all the time because the UI was updating too slowly. And so as you see these blocks where, as we mouse over it, we see that there's a bunch of styling that's occurring and a bunch of rendering that is occurring, which is actually swamping up even more than a full CPU. And so what was happening is the WinJS binding would run, it would see that it didn't have enough time, and it would just skip one of the notifications and wait for the next one, and then coalesce these together. Whereas in my rendering one down here, we see very, very regular pattern of like every one of these has a single JavaScript block, and the number is longer, and as we go through here, we see that we have kind of this tick which runs through, which says, oh, for every animation frame callback, there's a layout callback, and then there's an animation frame callback, and then there's a layout callback, and so there's this very regular beat to it of, I see animation frames happening, and then we're laying out, and then we're rendering, and animation's happening, and we're laying out and rendering. Now we can notice every once in a while, IE skips painting. So you'll see here, like here, IE just didn't bother to paint because it was running slow enough. But you can actually go dig into this and figure out why that is. And so in this case, the win we got, the reason why binding was actually net faster in this case was because it just decided to lie to the user. But you guys all caught that. So that lie was apparently bad. But again, measure, understand the cost, and understand that the template case was slower. Templates added features, but they added cost. So it's interesting to understand, should you use a template in all cases, or should you think about it as, could I just write the binding myself? And in some cases, you're like, yeah, I shouldn't. So the final thing I want to touch on in WinJS is ListView. So ListView is the canonical control. For both XAML and WinJS, the ListView is the kind of the quintessential control, the definition of kind of the Metro style. And it is the number one question we get about performance and how you optimize your applications. How do you make ListViews fast? What do you need to go do? And in fact, we got so many of these questions that for WinJS 2 in 8.1, we've added a new control called repeater, which all it does is it takes a data source and it stamps out a template again and again and again and again and again. And the reason we did that was because people said ListView is too slow because it virtualizes data, and as you scroll, it does a bunch of work to update the DOM, and so that you get this kind of infinitely scrolling surface, but that makes it flicker when you're on low-end devices. So we said, okay, great, we're going to give you an option, which is this repeater, which it stamps everything out. And now once it's created, you have a low startup time, you have a startup time cost, but it'll be infinitely fast at scrolling. Awesome. And then there's a set of purists who say, no, you shouldn't even do that. The repeater is a control. Controls are way too expensive. You should just do inner HTML. Just do a giant string concat, blat it into the DOM, and party on, away you go. And so we said, great, let's go look at that. Let's not look at the final result. Everybody avert your eyes. Great. Oh, wait, I ran the wrong app. Look at that. You guys want to see that demo again? It's really exciting. I went creative for my UI. Okay, so what that did, and it turns out that one of them was so fast you didn't even see it, it did those three options. Inner HTML, binding, or inner HTML, repeater, and ListView. And the numbers to the right are how long it took to generate those. And you'll see that inner HTML was, in fact, not quite the fastest. Might be somewhat, again, counterintuitive. ListView, fastest. Repeater, slowest. Awesome. Okay, that's kind of expected that the ListView might be faster because it's virtualized. It didn't create everything. And so when I scroll the ListView, which is on the right, which clearly you can see because it has all these features like selection and things that turns out this middle one doesn't do. So while inner HTML was faster, it gave up a bunch of features for that than that. But the big question, the big thing to go think about is what the DOM looks like for these things. So we've been talking a lot about cost in terms of time. Sorry, wrong button. The interesting question for me is, what's the memory? So we'll go run this guy and look at the DOM Explorer. That's an old profile. We won't look at that. Don't want you to get confused. Great. So let's look at our DOM Explorer, and we'll look at the repeater content. Sorry. The template content. And you look at this, and you see that's a lot of divs. Like, it created a lot of elements. That means there's a lot of memory being consumed. So the working set of this, I've traded off kind of scrolling performance for memory. And so again, you just got to think about the cost, like whether or not that makes it. So the repeater, for example, the repeater wins for very small lists. For very small lists, repeater's awesome because it doesn't have any scrolling overhead, it gets out of your way completely, and it runs relatively reasonably. But it's still slower than inner HTML because it's doing everything one at a time. But you get data templates, and so that gives you some, developer productivity. Whereas ListView delivers a lot of that, but it has the panning overhead. So there's this trade-off that you need to think through about how to make these decisions. So what does that all mean? Besides me saying a lot, go understand things. Go understand the physics of your platform. What this means is that, first off, I'm not going to tell you that HTML is better than XAML, or XAML is better than HTML, or DX is the only one true answer for anything. Like, the reality is you need to understand these and their tools to go accomplish your job. And the languages equally are about trade-offs, about developer productivity, libraries you can access. JavaScript has a raft of libraries available, but C#, we have so many developers out there who know C#. CX, while it looks on the surface like it's going to be a great way to leverage C++ developers, there's cost you need to understand. But equally so, as we talked about with many of these, is that those features, it turns out they come with features. And so, like, supporting accessibility, supporting internationalization, supporting, the ability to graft elements in, those are all features that actually add value. And so it's not purely, hey, drop to the metal and try to draw pixel yourself. And really it is about deliver the best experience per watt. Measure the results and go look at it. And it is really, go look at it in context of the questions you need to go answer. What is the team you have? What experiences do they have? Which of those examples would they have figured out? Which of the assets do you already have? How do you want to go monetize it? How do you want to deal with the operations? And if we go look, DX requires C++. It gives you the max expressiveness. DX gives you access to all the hardware. You can do anything the hardware can do. The games that we saw this morning on tiled architecture that required some crazy NVIDIA box that can do just amazing things, that you do with DX. And it gives you the most performance control. You'll notice I didn't say the fastest. DX is not the fastest. It gives you most control because it is really easy to do really stupid things in DX. XAML gives you a language choice, and you get better interop today. That's something that just is true in the bits that you get. WWA, it definitely gives you a lot of web assets, and there's a lot of web assets out of there, but it limits your choice of language. So, with all of those caveats, with all of that in your context, I will actually give some concrete guidance. First, if you're writing a game, just use DX. Like, it is the way to write a game. If you're using Unity or Cocoa 2D or Epic Engine, that's also great. They use DX as well. If you are writing a first-person shooter and you are using Canvas in HTML, I'm sorry, that is not the right answer. That is not going to deliver you the best experience per watt. It remains to be seen. I haven't seen the data on whether or not WebGL is going to go far enough in the HTML space to be able to be good enough. But I love the idea of game engines like Unity, which have a high-performance C++ engine that provides a high-level abstract layer, and then you can write scripting for that in any language you want, because that's great. The engine's fast and optimized and domain-specific. But if you're trying to build an engine in Lisp, you're also wrong. If you have a website today, don't bother trying to have a big debate. Just go use WDBA. You'll be able to leverage your assets. It'll be a far easier port to JavaScript from JavaScript than it will be to port to something else. If you use WPF and Silverlight today, skip all this. Just go use XAML. It's easy. It's familiar. There are some changes. There are some gotchas, but overall, it's going to be a very, very easy porting. The last one is the next one is somewhat controversial, which is if you're writing a shared component, it should be written in C++ code. The reason for that is that you don't necessarily know all of your customers. If you know every one of your customers, fine. You can write in whatever language they would like. If they want you to write in C#, that's great. But if you're writing a library that you intend for lots of people to go use, and you want to go put it up on the web, and you want people to go take advantage of it, it needs to be native code, because you don't know. They may want to run it in JavaScript. You do not want to load the CLR into a JavaScript app. If you're writing a pure C++ app because you're trying to control the threading constructs, and suddenly some library that you want to go depend on sucks in the CLR, which spins up a GC thread, you're going to be pretty frustrated. Now, that said, there are, of course, exceptions to that, but I mean, just as a general guidance, in the same way, I'm sure you can come up with a game that it should be written in JavaScript or something, but in general, they should be DX. And finally, the reality is, I want to give you a get out of jail card. If you love C# and you just love C# and you just want to keep loving C#, we love that you love C# and you should love to continue to love C#. And so please continue to love it and just go use XAML. C++, just keep with it. If you love JavaScript in the web, it's okay. People try to make a performance argument between XAML and HTML, but the reality is that 80% of the underpinnings of both frameworks are the same. They both ride on top of all that DX content we talked about at the beginning. DWrite, D2D, DX, all that stuff is the same. And so really you can get incredibly, incredibly good performing apps on top of WDBA and JavaScript. So I mean, really, if you love these things, just do it. It's great. So really, I want to wrap up by saying, that in the end, this is about us all delivering apps and a platform and an experience that delights our users. That's what sells apps. That's what makes people enjoy using our platforms. That's what makes people enjoy using the devices. That's what makes people love all the work that we all do. And it's hard. We have to work together on that. And so I think that we as the platform providers need to do work to make things faster and easier and better and give better tools to make it more understandable. I think having the energy profiler built into VS is a great example of us trying to go there. And we all succeed when that end user experience is fabulous and great and exciting. And really, to me, this comes down to this new measure of experience per watt and how you deliver more value without tanking the battery life and without making the machine burst into flames is kind of the magic there. They injected this slide on me. Please evaluate your session. Rate me. Great. I'll leave that up so you can scan it with your Windows phone, because clearly everyone has a Windows phone in this audience. No one would have anything else. Thank you very much, and if there are any questions, we have a few minutes if you want to come to the mic. Yes, sir. Can we get the mic over here on the stage left? Nope, there it goes. You're good.
So, quick question on C#.
On C#, yes.
You used composition target rendering in your demo, which is death to performance. Why did you do that?
Wait, say that again?
So you used composition target rendering, which is a static event in XAML, which fires every time a frame renders. Why did you do that? That's kind of death for performance.
Why did I hook composition target rendering in the XAML event?
Yeah.
That is a great question. Which demo was it they saw it in? The C# XAML, the animation test? So there's two things that are happening here. So let me explain this code real quick. So in the composition target rendering, one of the things that I'm doing here is I am calling bind on each one of my objects. The bind method was the thing that actually constructed the object and set up the rendering. And I wanted to do that so they were all offset, so they would spin at different speeds or at different times. And so that's the one thing I'm doing. And then the other thing I'm doing is I'm actually ticking my data model. I'm ticking the timer. So I have a step timer, which is what I'm using to show the frame rate. So the frame rate was in the app instead of using the debug UI. So you can think of it as this is creating the UI. So once per frame, I allow myself to go generate more UI so that I'm not swamping it. And then this is just so that you guys got a frame rate counter that you could look at and go, yes, we love it. Other questions? Anyone? No? Fabulous. Everyone knows what to do. Go write apps. Make money. Thank you.